Hi guys, so in this video I'm going to show you 17 array methods in JavaScript, including higher order array methods such as forEach and map. All of these these are sort of the most useful array methods in JavaScript, I think, and I think having these methods at the sort of top of your head when you're writing JavaScript, I think really helps your problem solving ability, and just helps you to sort of find solutions to problem in a nice sort of clean and quick way. So yeah, all of these are really useful methods, and we're going to discuss how each of these work and go through a simple example or two for each of these methods. So to get set up, I'll show you how I've set up. So I've created a script.js file and an index.html file, and in the index.html file I've simply just used emit. I've done exclamation mark enter to get standard boilerplate HTML, and then I've linked in the script tag. I've linked in the script like so, and I've then opened this up with live server. So there we are, and then we just right click, inspect, go to the console, and then if we console.log hello, we have an issue. What's the problem? Script.js, that should be, sorry. There we go. So there we can now log things to the console. So that is the way we've set up. Okay, so let's get started. Okay, so first of all, let's create an array of names, and we're going to sort of work on this array with our array methods. So let's create Danny, Joe, let's create Sarah, and Molly. Okay, so the first array method we're going to look at is toString. So let's create a variable called string names, and we're going to put that equal to names dot to string. And now let's have a look at what string names looks like. So if we log that to the console, we can see we get Danny, Joe, Sarah, Molly, and this is all a string. So it's converted this array to a string, and it's separated all of the values in the array by a comma. So it's created essentially a comma separated list as a string. So that's what toString does. So it's pretty straightforward. That's all toString does, really. Very straightforward method. So let's now have a look at the join method, which is very similar to string. So if we do names.join, and with join, it's very similar to string, but we can specify the separator. So with toString, it's always a comma. It's always a comma separated list. With join, we can actually specify the separator. So if we put a comma, and then if we log that to the console, we can see we get exactly the same as we got with toString. But if we now decide to put space and then a space, and then save that, we get Danny and Joe and Sarah and Molly. So we get space and then the element, space and the element. So with join, we can specify what we separate the elements in the array with. Okay, so it's a string as well, converted to a string, but we can specify the separator. So that is the way that toString and join work. Next, we're going to have a look at concat. So the concat method is used to combine arrays together. So let's create another array called names2, and let's put in some names. So John, and let's go with Tom. And what we can do is we can join names2 onto names with the concat array method. So if we say names.concat, and then we say names2, and let's actually call this joined as a variable, and then log that, we can see we've got Danny, Joe, Sarah, Molly, all of the names here, and then we've joined the elements from the names2 array, so John and Tom. We can also add another array, so let's just copy that down. We've got to think of some more names now, so let's go with Delia and Smith, and then if we can cat names 3 on here, we can see we've got all the first array elements from the first array, and we've got all the second array elements, and then we've got all of the elements from the names 3 array. So as you can see, it's joining all the elements from each array onto the end of the first array. Okay, so that is the way Concat works. It's used to combine arrays together. So next we're going to have a look at Splice. So Splice is used essentially to remove elements from an array, and also you can add some new elements in. So let's see if we say names.splice. So the first argument of Splice is the start index. So let's say we want to start deleting, let's say we want to delete Joe out of this array. So Joe is at index 1, so 0, 1. So we're going to start at index 1. And then the second argument of Splice is how many elements we want to delete, starting from Joe. So if we deleted one element, we would just delete Joe, and the names array would now be Danny, Sarah, and Molly. So if we log that to the console, we get Danny, Sarah, and Molly, just like we expected. So the important thing to note about the Splice method is that it actually mutates the original array. As you can see, names is no longer what it originally was. Joe has been removed from this array, so it's been mutated. And that generally mutating values is not a good idea because it can add bugs into your program. For example, if many functions in your program were using this names value, and there were lots of different functions that were altering it, it's very hard to predict what names are actually in this names array. So one way of working around this mutation problem is to create a copy of names and then work on that copy. So what we can say is we could say names copy equals, and then we could create an array and spread in using the spread operator names. So what that's going to do is it's going to spread in all of the elements from this array into this array. So we've got a names copy, we'll call that. And then what we can do is we can work on this names copy, and then console.log this names copy if it lets me. So names copy, and as you can see, the names array here has not been mutated. It's still exactly the same, but now we have our names copy array, which has been mutated because Joe's been deleted. Okay, so that's how you can work around the mutation issue if it becomes a problem. So let's now show you how to actually use Splice to add in some new elements. So let's say we wanted to remove Joe and Sarah and replace it with Bill and Bob. So what we can do is we can say we want to start deleting from here. So we can say start deleting at index 1. We want to delete 2 items, 1, 2. So we say 2. And we want to add in Bill and then Bob. So let's add Bill and Bob. Okay, now if we console.log names, we can see we've got Danny, Bill, Bob, and Molly. So that is Splice in a nutshell. It's where do we want to start deleting from, how many items do we want to delete, and what do we want to add in. So that is Splice. Next up, we're going to have a look at Slice. It's very easy to get these two mixed up, and you will probably have to look them up many times during your life as a JavaScript developer. But Slice is essentially used to slice out parts of an array. So let's say let slice equals names dot slice, and in here we have a start index just like Splice, So let's start from Joe, index 1, and then this is the index for which we want to slice up to. So if we wanted to slice up to, let's say we wanted to slice Joe and Sarah out of this, we wanted slice to be Joe and Sarah, what we would do is we would specify the index of 0, 1, 2, 3, because slice is up to but not including the last index. So if we put 3, we start at index 1, and then we are slicing up to but not including index 3, so 0, 1, 2, 3. So up to but not including this value, so we'll get Joe and Sarah. So now if we log that console.log this slice, we'll get Joe and Sarah. And if we console.log the names array, we'll see that it's not changed because slice doesn't mutate the original array. It just takes those two items and puts them into and returns them. It doesn't touch this. It doesn't mutate this original array. Okay, so that is slice. You simply use it to slice out some values from an array. You take a slice from an array, and if you don't specify this last argument, the end index, what you'll actually get is it goes up to the end of the array. So it starts at index 1 and then it'll just take the rest of the array. So if you just want from here up to the end, you just put 1, and as you can see we get Joe, Sarah and Molly. So that is slice. Next up we're going to have a look at indexOf. So indexOf is used to find the index of a certain value in the array. So let's say we were looking for Joe again. What we would do is we would say what is the index of Joe, and the index of Joe is 1. So let's see, so let's put index equals names dot index of, and let's say we want to find the index of Joe, and then if we log this index, you can see we get 1. What is the index of Joe? It is 0, 1. Okay, so it finds the first time that Joe appears in the array. If we put Joe here as well, we would see that it still returns 1 because it finds the first Joe in the array. And what is the index of the first Joe? It is 1. So it searches from left to right. If we wanted to find the last index of, we could actually use a method called lastIndexOf, and we can see that we get 4 because the last index of Joe, when we search from right to left, is 0, 1, 2, 3, 4. So that is the way lastIndexOf works. Okay, so next up we're going to have a look at the flat array method. So first of all, let's create an array of numbers. And we're going to have a nested array in here, so 5, 6, and then after that we'll go 7. So if we log this to the console, we've got an array of numbers, and then here we've got a nested array at one level deep. Okay, so let's just say this is the 0 level, and then within this we've got another array which is at level 1 with 5 and 6. So it's a nested array within. It's an array within an array. So let's say we wanted to flatten this down into sort of one-dimensional array. So we just wanted it to be 1, 2, 3, 4, 5, 6, 7 without this nested array. So for that we can use the .flat method. So we can say let flat equal nums.flat, and then we can just call it. And then let's log flat to the console. And as you can see, this nested array has been flattened out, and we now just have 1, 2, 3, 4, 5, 6, 7. So by default, flat will only flatten down by one extra nested layer. So for example, if we got rid of this 7 and we had a third array at a sort of second level deep, we could say 7, 8 in here. Let's go back out and say 9. So now we've got our first nested array at level 1, and then we have a second nested array at level 2. So now if we call flat, we can see it flattens out this first this array, which is at sort of level 1, but it hasn't flattened out this array here. So we've got 1, 2, 3, 4, 5, 6, but then we've got 7, 8, which is still in this nested array. Okay, so if we wanted to flatten out more than one layer, at more than one level, so by default it flattens by one level, we could specify 2, and now we specify this level and this sort of second nested array with 7, 8 in it, and we just get our linear one-dimensional array returned. Okay, so that is how flat works. Okay, so now we're going to have a look at some higher order array methods. So first of all, what is a higher order array method? So a higher order method, or a higher order function, is a function that accepts functions as arguments and or returns a function. So higher order functions are functions that operate on other functions. So that is confusing, so let me just show you what that means. So forEach is a very simple higher order array method, and all this does is it simply loops over each element in the array, and then what we can do in here is we can write a callback function, and then we can do something in here. So forEach essentially loops over each element in the array, and each time we loop over the element, it calls this callback function. Okay, so it calls back this callback function. So in this callback function, we get access to the current element. So initially, n is going to be equal to Danny, and then we could just console.log n. Okay, so each time we go through the array, we are console.logging the current elements. So initially, we're going to get Danny, and then we're going to loop through again, and we're going to call this function, and we're going to log the current elements, which is Joe, and then we get Joe, and you can see we go on and on and on. So that is the way forEach works. So you can do pretty much whatever you want in here. Let's see, we could say let's count equals 0, and then for every time we go through we could say count plus plus, and then at the end we could log count, and we can see we just get the length of the array. So that'd just be a long-winded way of finding the length of the array. So that is when you would just use forEach if you wanted to quickly loop over every single element in the array. It's essentially just a for loop, so just a bog standard for loop. So like this, we can say let I equals 0, and for I is less than names.length, and then we increment I each time. It's exactly the same as doing this. So for console.log, we can say names current index, and as you can see, we get exactly the same as we got when we just console.logged the names here. So it's exactly the same thing, but it's just a nice, shorter, simpler way of looping through every element in the array. Of course, if you needed to specify the start index, such as 2, and then we wanted to increment I by 2 each time, then what have I done here? Let's see, refresh. Just destroyed Chrome. Close that down if we can. Okay, let's get rid of that for now, comment this out for now. As you can see, we just get Sarah and Joe because we're starting at 0, 1, 2. Second index, so we log this, and then we plus 2, so we go 1, 2, and then we log Joe. So there we go. So if you need more custom control over what you're looking over, you just use a standard for loop. Or if you just want to loop simply over every element in the array, we can just use the forEach. Okay, so next up we're going to have a look at .map. So let's create an array of numbers this time. So we're going to go 1, 2, 3, 4, 5, 6. Okay. what we want to do is we're going to use map to loop over each element in the array, and we're going to double each element in the array, and we're going to map it to a new array. So let's say let double equals nums dot map, and dot map takes a callback function with access to each number on each callback, and we're going to say n times 2. So we're going to return n times 2. And now if we log doubled, we can see we get a new array where every single item in the array has been doubled. So that is what map does. It loops over each element in the array, and it executes a callback function where we have access to the current elements, and then we can return whatever we want. If we want to times it by 3, times 2, if we want to do whatever, and whatever we return, it puts it into a new array. So it builds up a new array as we go. So basically the first one run through, we would have an array of 2, because we 1 times 2. And the second run through, we'd have 2 times 2, which is 4, and so on and so on. And then at the end, this array is returned from map, and we are assigning it to this variable, which we'll log in here. So that's the way .map works. Okay, so it's used, if you want to return a new array from the first array, .map is better to use than forEach. It just makes more sense to use map. And it's just, you wouldn't have to write as much code. So that is .map. So the next thing we're going to look at is filter. So if we create a array of blog posts, so let's just call it posts, and this is going to be an array. Okay, so in here, what we're going to do is we're going to create some objects, and we're going to have, each post is going to have a title, so post 1, and an author, so let's just call it Dan, and then let's just copy this down. So we've got 3 posts, it's going to have post 2, post 3, and then let's have Dan, and then Sarah. So what we want to do is we want to filter out, we want to create a new array where Dan is the author. So we want to find all of the posts, we want to filter out all the posts that aren't by Dan. So this is where we can use the filter higher order array method. So we can say let Dan's posts equal posts dot filter, and then we have a callback function here where we get access to the post, current post, and then we can say filter through all posts, so posts dot author equals Dan. So filter, allow all posts where Dan is the author to filter through into the new array. So if we now log Dan's posts, we can see we've got an array of objects where Dan is the author. If we wanted to find all of Sarah's posts, we could just do the same thing, and now we get just Sarah's posts are filtered through. Okay, so that's the way filter works. It's used to filter, allow certain, it only allows elements in the array that match the condition here to pass through into the array that's returned at the end, which we are assigning to this variable here. So that's the way filter works. Okay, so next up we're going to have a look at the reduce higher order array method. So let's create an array of numbers again. So let's just go 1, 2, 3, 4, 5, 6. Okay, and let's say in this array we wanted to find the total of all of these numbers in the array. So it will be 3, 6, 10, 15, 21. So we can use the reduce method to essentially reduce an array down to a single value. So that's what reduce does. So let's see, so let's have a variable called total, and we're going to say nums.reduce. So reduce takes a callback function, and in this callback function we have access to, well, we have a total argument called total, or sometimes you'll see it called accumulator, and we also have a second argument, which is the current value, so current val. Okay, and what we can do is we can return total plus the current val. Okay, and then if we log that, we get total is 21. So how does this actually work? So first of all, we loop through every single item in the array. So the current value is just the current item that we are looping over. So initially, the current value is going to be 2. So we actually start here. Now initially, total is going to start at 1, and the current value is going to be 2. The next time we loop through, current value is going to be 3. Then the next time we loop through, current value is going to be 4, 5, and then 6, etc. So now this total value is remembered between every time we call this callback function. So initially, total is going to be 1, and current value is going to be 2. And then what we are returning is total plus the current value. So the total is 1, current value is 2, total plus the current value is 3. So that is now our new total value. So that's remembered the next time we loop through. So the second time we loop through, total is now 3, and our current value is 3. Okay, so then we return the total, which is 3, plus the current value, which is 3, and that is 6. So the total is now 6. So the next time we loop through, the current value is 4, and the total is 6. And then we return 6 plus 4, which is 10. So that is our new total value. So then we loop through again. Current value is 5. Total is 10. 10 plus 5 is 15. And then we loop through again. Total is now 15. And the current value is now 6. So 15 plus 6 is 21. And that is our final value. We've got to the end of the array. We can't do anything else. That is returned, and we assign it to the variable called total, and we log it, and we get 21. So that is how reduce works. If we wanted to start from a different total, so total is by default, if we don't specify, the first item in the array. So if we wanted to specify what value we start from, so if we wanted to start counting from, say, 10, reduce takes a second argument. So the first argument is this callback function. The second argument is our starting value for total, or the accumulator. So if we start from 10, we can see we get 31 because we're starting as the total is 10, and current value will now actually be the start here. So if we don't specify the start number for total, then total will just be the first value in the array, and current value will be the second value in the array. But if we specify where we want to start from, so if we want to start from 10, okay, initially total is going to be 10, and the current value is going to be 1. So then we do 10 plus 1, which is 11, and then total is now 11. Current value would be 2, the second loop through. So we'd have 11 plus 2 is 13. So then we keep on going through. So 13 plus 3 is 16. And we have 16 plus 4 is 20. 20 plus 5 is 25. 25 plus 6 is 31. And that's what we get at the end. So that is the way reduce works. And I just want to show you one common use case for reduce. It can be used to find the max value in an array. So let's see, so we say A and B. We can actually return math.max A, B, and we start from minus infinity. So we now see the max value in the array is 6. So the way this works is A is essentially the thing that has been kept track of, the max value. So we start from minus infinity. Anything bigger than minus infinity is going to be the new value for A. So let's run through how this works quickly. So initially, the starting value, which is A, is minus infinity. Okay, so the smallest possible number you could imagine is what is A going to be. That's what A is. So A is minus infinity, which is a very, very small number essentially. So next time we loop through, the first time we loop through, A is minus infinity and B is going to be 1. And then we're going to find the max. What is the bigger value, minus infinity or B, which is 1? Well, it's B. So now A becomes 1. Okay, so the next run through, we've got A is equal to 1 and B is equal to 2. And then we find the max. What is the max between 1 and 2? Well, it's 2. So now A becomes 2. Okay, the next run through, A is equal to 2 and B is equal to 3. What is the max? It is 3. So this array is in order, so obviously every time we go through, we're going to get a new max. But let's say we put in, let's say we put 1 here. So 2 would be the max up to this point. So B would be equal to 1. Then we find the max. What is the max between 2 and 1? Well, it's still 2. So A would still be 2. And then we would move on to 3. And then the max would be 3. And eventually we get the maximum value returned at the end. So a better name would be max. And then we log it. And then we get 6. So that is reduce. It takes an array and it reduces it down to a single value. Okay, so that is reduce. Okay, so next up we're going to have a look at the sum array method. So that is .some, not sum. And the way this works is we check if some array values pass a certain test. So for example, if we wanted to check if some of these values are greater than 4, and if they are, we want to return true. So let's say is greater than 5. What we can do is we can say nums.sum, and then we get access to the current number in this callback function, and we want to say n greater than 5. So let's log this down in the console, is greater than 5, and we get true because some values are greater than 5 in this array, because 6 is greater than 5. Okay, so if we now put greater than 6, for example, there are no numbers greater than 6 in this array, so we would get false. Okay, so let's go back to 5 is greater than 5. So what is happening? Let's actually walk through what is happening. So first run through, n is going to be 1, and we are checking here, is n greater than 5? No, it's false, so we move on to the next one. Is n greater than 5? No, so we move on to the next one. Is n greater than 5? No, 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 and yes. So then we can return true. But let's say we put a 10 here instead. What would actually happen? So the first run through, n is going to be equal to 1. Is 1 greater than 5? No, it isn't. So we move on to the next one. And we say, is 10 greater than 5? Yes, it is. So we can just return. We're done. Because obviously some of the numbers in this array are greater than 5. And sum just means is one or more of the values in this array greater than 5. So it would just return early. We'd just return true and we'd be done. So that is the way sum works. It just finds if one or more values meet a certain condition. So now we're going to have a look at a very similar function called every. So every, it looks through our array, and if every single number meets our condition, then it returns true. Otherwise, it returns false. So it's kind of the opposite of sum. So let's say let all greater than what should we do? All greater than 0. So we're going to go with nums.every. We're going to have a callback, and in here we can write our test to see if all of the numbers are greater than 0. So we say n greater than 0, and if we log this to the console, so what do you think is going to happen here? We're going to get true or false. Well, let's have a look. Are all of the numbers in this array greater than 0? Yes, so we should get true. So if we log it, we get true. If we put all greater than 1, we get false, because not all of the numbers are greater than 1, because 1 is not greater than 1. So if we go back to our 0, 1, we can see that on the first loop through, n is going to be equal to 1. Is 1 greater than 0? Yes. And then we're just going to carry on looping through. Yes, 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 yes. But now if we put a 0, let's say here, we get false, because 0 is not greater than 0. And all of the numbers, every one of the numbers now, is not greater than 0. So if the first run through, 1 is 1 greater than 0. Yes, 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 no. So then we return from this function. We're not going to look at these. All the numbers are not greater than 0, so we can just return. So that is the way that .every works. Very similar to .sum, but rather than just some of the numbers meeting a certain, passing a certain test, all of the numbers, every single one of the numbers is going to pass a certain test. Okay, so next up we're going to have a look at the find array method. So what find does is we can use it to find a certain value in an array. So we can say let's say we wanted to find the mayo item. So we've got an array here of objects, and each object is an item with its quantity. So let's say we wanted to return the mayo object. Okay, we wanted to see what the quantity of mayo was. So we could say mayo equals stock.find. Now we have a callback function which keeps track of the current element that we're looping over. So let's just call it s, and we can return. This is where we write our sort of test, our condition. So we say s.item equals mayo. So we want to find the mayo item. Okay. So then what we can do is we can log mayo to the console. Now we've got mayo. So if we wanted to find the quantity, we could just do .quantity, and there we go. We got the mayo quantity as 9. So find is just used to find a value in the array, the first value in the array that matches our sort of little test that we write here. And now, very similar to find, we also have findIndex. Okay, so if we just get rid of this .quantity, findIndex finds the index where the first element in the array matches our sort of test statement. So the first element in the array that matches s.item equals mayo is this one. And what is the index of this? It is 0, it is 1. Okay, so it returns the index. So that is find and findIndex. And lastly, we're going to look at the sort method. So let's create an array of names. Let's go Danny again, and Joe, and Molly, and Sarah. So if we wanted to sort these into alphabetical order, we could say, let's just call it alf equals names.sort, and this would actually put our names array in alphabetical order. So if we log that, and we get alf, we get Danny, Joe, Molly, Sarah. So this is actually already in alphabetical order. So if we just mixed it up a bit, and we put Joe here, get rid of that. Okay, so now we get Sarah, Joe, Danny, Molly, put in alphabetical order as Danny, Joe, Molly, and Sarah. So by default, sort works on strings, so it orders by the sort of string value. So if we wanted to sort an array of numbers, so let's create an array of numbers now. So if we say nums equal, let's go with 2, 4, 1, 8, 5. Okay, so we've got an unordered array here, and let's say we wanted to sort that. So let's say sorted equal nums.sort. We just called sort. Let's see what we get. As you can see, it has been ordered correctly, and that is because these are one-digit numbers. So for one-digit numbers, JavaScript knows that 1 is less than 2. But let's say we have two-digit numbers, say 11. Now we can see JavaScript is just looking at the first digit and ordering by that. So 1 is less than 2. That is why we've got 11 at the start of the array. But we know that 11 is the biggest number in this array and should be at the end. So how do we fix this problem? Well, we can pass in a callback function. Well, we've got AB and we return A minus B. And now we get the correct order. Okay, so the way this works is we've got A, which initially is going to be 2, and B, which initially is going to be 4. Then we have this little check statement. So it does A, which is 2, minus B, which is 4. The 2 minus 4 is minus 2. And if this value evaluates to a negative value, it knows that A is less than B. Okay, so that means that A should come before B. But if, say, if B was, let's say if A was greater than B, then this will be a positive value. And if it's a positive value, it knows that A should come after B. Okay, so that's the way sort works. To order numbers, we have to put this little callback function in. If we wanted to put it in reverse order, we could just say B minus A. And now the array will be in reverse order. Okay, so it'll be in descending order. So that's the way sort works. So that is everything I wanted to talk about in this video. So we've covered quite a few different array methods and higher order array methods. Hopefully that video is helpful. If it was, please give me a like and subscribe to the channel. Cheers for watching, and I'll see you in the next one.